By the end of today's video, you should be able to understand how to write simple autonomous pathing programs using PedroPathing for FTC robotics. We should back up, wait about 3, 4, 5, and then we should transition to our next state. Beautiful. I'm Coach Brad, and I've been teaching robotics and design for over a decade now, and I've coached national champion FTC teams. And today I'm going to walk you through how do you create a sample autonomous program in PedroPathing. I'll step you through how to do all the imports, how do you figure out what your path is and where you know where your robot in space, the easy ways to do that, and then I'll show you how you can set up a simple state machine so you can transition from path to path so you can set your robot to move up around space. Now, a couple of prerequisites before we get started. I do assume that you have PedroPathing installed on your robot already using the quick start guide. I'm also assuming that you have your robot fully tuned. If you have not done those yet, check out my tutorials in the link down below to be able to do that before you continue. So first things first, we're going to head on over to our Android Studio. And we're going to make a new class in here. And we're going to call this one just a sample auto pathing. We'll always add this to our GitHub as usual. And then the first thing that we need to do is we need to make sure this extends the op mode class. We're also going to make this an @teleop. And it's going to get angry at us because we have to always put in 2 methods for an op mode. We have to make a public void init. And we have to make a public void loop. Otherwise, our op mode is not actually valid. Now, the next thing we're going to do is going to set up some of our initialization points here for PedroPathing. We're going to make a new private follower called follower. And we're also going to make 2 different timers so we can keep track of these things without having to break. So traditionally, programming uses sleeps to be able to have these methods set up. So you might run a servo, sleep, and then let that servo run for so many seconds and then move on. The problem with using a standard sleep is that in robotics, it's a terrible idea. You want to be able to read a sensor, move on a path, read a sensor, move on the path, and do those things simultaneously. The problem with that is for the most part, most microcontrollers only have a single thread. So it only allows us to do one thing at a time. So if we put in a sleep, that means we're not able to do other things like check our sensors. So we're going to use some timers to be able to allow it still have time-based communication, but still allow us to read and do other things while those timers are running. So we're going to make a new private timer. And in our case, we're going to make 2 timers. We're going to make one called path timer and one called a op mode timer. Now for this timer one, it's not going to automatically import in our statement because we don't want to actually import the Java util timer. Instead, we're actually going to come up to import. We're going to do com.pedropathing.util.timer. And of course, if you spell import properly, that will actually work for you. Now, the last thing we're going to make up is we're going to make up something called a state machine so we keep track of which path state we're currently in. Because how PedroPathing works is effectively you're going to build paths from position 1 to position 2, that's path 1. Then position 2 to position 3, that's path number 2. Then position 3 to position 4, that's path 3, and so on and so forth. And you build together these different paths to be able to chain them up. So to be able for us to keep track of these paths, we're going to use something called a state machine. If you're not sure how a state machine works, don't worry, I'll step you through it in this whole tutorial here. If you want a little more in-depth knowledge, I've also got a video in the description below on writing state machines. So we're going to make a new public enum or enumerate. Oh, I cannot type today. Public enum or enumerate called path state. And inside this path state, I'm going to need curly brackets. And for my states, I like to say the start position to the end position. So I'm always going to have some sort of where am I starting and then where am I ending for my states. And I find that it helps me keep track of writing my own states here. So I know that, oh yeah, this state means that I'm moving from this position to this position. I also like to have 2 different states for the decode season specifically. I have one state that is drive, and this is some sort of movement state where we're expecting that we're actually moving around the screen. And I have another state called shoot, which is actually going to attempt to score the artifact by launching our balls at this point. There are 100 ways of doing this. I'm not saying this is the only way to do it. This is just a way that makes sense in my brain personally. To be able to give you an idea on where it is we're going, we're going to use the PedroPathing visualizer. So if I come to visualizer.pedropathing.com, it will allow me to be able to draw different points on my screen and move my robot around. So to give you an idea on where we're going to create one path that starts us here and moves us back to be able to fire. Then we're going to create a second path where we come in, we rotate to pick up these balls. We're going to create a third path to bring us back to this scoring point. And then we'll create a fourth path to remove us, to take us off. Oh, I cannot undo that. Ooh, all right. And then we'll create a fourth path that allows us just to, from that score position, just to step off that launch line so that we can make sure we get those 3 ranking points at the end. Or sorry, not 3 ranking points, we can get those 3 points and another point towards those ranking points. So for now, on this simple one, all we're going to do is drive back here and then stop. So we're just going to put a single path so we can make sure and verify that this works as we would expect. So in our case, for our path states, we're going to have 2 states right now. To let us know we're going to drive, we're going to go from start position to the shoot position. And then I'm going to have another position here called shoot, and I'm going to say preload because we're going to have one state where we're actually going to shoot those preload positions. Then we need to actually create that path state. So I'm going to say a new, oops, I'm still in capitals, path state, and we're going to call this one path state. So that actually creates a variable of our enumeration here. So next up comes time to actually create those poses. And now it's time to come back to the PedroPathing path visualizer here. So on this path visualizer, you have several of the things that we can work through. I'll zoom in a little bit so we can see. So you have your starting position here, which is of course your start point, and it shows your current robot position. And then you have the end point from where you need to go. So what we want to do is we want to set ourselves up where we'd actually start in that position. And in my case, I'm going to set up so that my robot corner is touching on this goal line, and I'd basically be in line with the goal at this point in time. So I might actually need to rotate my heading a little bit, so we can use this tile here. Actually, I'm not going to. I'm just going to make sure that I'm going to be set up parallel and perpendicular. So my start position is an X value here and a Y value here, and our current heading is 138. So let's go ahead and actually start creating some of those positions. And to do that, we create poses, and poses are individual points where we are inside of the map. And in this case, we have 2 poses. We have a starting pose where we start initially, and we have a shooting or scoring pose. So in my case, I'm going to make a private final pose with a capital P, and we're going to call this one the start pose, where we're starting that initial position. And that is equal to a new pose. And the pose object takes several different values. The first one takes this as X. So I'm going to go over here to the start point. I'm going to copy this, and I'm going to paste it in as the first argument here. Now, because I'm using a European keyboard, I'm going to make sure that I have to delete that comma to be able to put it into a period, because it's obviously commas are how we separate arguments. Then we're going to take our Y value. We'll do the same thing. If you're using an American keyboard, you're likely okay with not having to copy and paste with that additional comma. And the last thing we need to put is our heading. And for our heading, the visualizer gives it to us in degrees, but the pose object expects it in radians. So we're actually going to say math.toRadians, and we're going to put in our heading here, which is 138. So I'm going to say 138, and we're going to finish it off with a semicolon. So that's our first pose. So that is our start pose. Now we have to make a shooting pose. And this is the same pose that we're always going to end up shooting in. So we're going to make a new private final pose. We're going to call this one a shoot pose, and we'll make a new pose. And now it comes time to decide where we're actually going to shoot our pose from. So I could just set my endpoint up, or I could just grab my robot and drag it to where I think I want to shoot from. And in this tutorial, I'm just going to come back by, let's say, 1.5 tiles, something like that in that range. So we're here. So now I can just grab my current robot's position. So I'm going to grab this current position here, make sure I grab this start point of this X. So we'll go ahead and put this in. Again, delete my comma so I have a period. We'll grab the other Y value. And then, of course, we need to do our math to radians again. And in this case, we want to actually keep the same heading. So we're going to be at 138. For now, I'm just going to move this back so we can set this up. And again, it'll be math.toRadians, and we'll put in 138 as our argument with a semicolon. Now, to give you an idea of where we're going, we can click this little play button, and it's going to show what our robot's going to do. Oh, and right now it's turning because I have the endpoint at 180, so I'm going to do 138. So if we were to click play, you'll notice that the only thing that our robot is going to do is just drive directly backwards. So we're going to keep a really simple path like that for now before we get more complex and add some additional points in. So next up comes to actually initialize our paths. So we have our state machine to be able to keep track of which state we're currently in. We have our poses for where we're actually going to be. And now it's time to actually create those paths for PedroPathing specifically. Now, PedroPathing has two ways you can do things. You can create a simple path or a path chain. I prefer to create all of my paths as path chains because it allows you to add a little more extra features to things later without making it any more complex to still make simple programs. So I'll make a new private path chain, and we're going to create several variables here. Just like when we made a timer, we made two separate timers. We're going to create multiple path chains here, but in this case, because we only have one path that we're going to keep track of here, we're only going to write in one. So for this one, I'm going to call this one drive from start to shoot. So again, just like I have my state machines here where I say drive from start position to shoot position, I'm going to say from start position to shoot position. And that really helps me keep track of which path chain I'm following. Now it's a misnomer, and that is called a path chain. This does not mean because I just have one path. That's just simply an object called path chain. I wish there was a slightly better name for it, but just as long as you understand that this is a single path, that's all you need to know. Now, as far as my understanding goes, the way that PedroPathing works is you need to build all of your paths first before the autonomous actually starts up. So they have a function here that allows you to actually build those paths. So we're going to make a new public void called build paths. Takes no arguments. And here's where we actually start building our paths. The way that a path is actually built is you put in coordinates for starting pose, then you put in coordinates for the ending pose. That's for your entire path. So because in this current example, the only thing we're going to do is have a single path where we simply move backwards. We have one starting point and a second ending point, or pose. So here's where we're going to put in our drive start position to shoot position. So I'm going to say that drive start position to shoot position is equal to a follower dot path builder. And then inside path builders, we have a couple different values we need to add in here. I'm going to put in a dot. I'm going to say add path. And inside our path, I'm going to put in a new Bezier line, because for this point, I'm only just going to use straight lines. I could add curves to my paths for now, but lines keep things simple. So we're just going to go and start in a line. We're going to choose our starting pose, which in this case is just called start pose. And then we put our ending pose, which in this case is shoot pose. And once we've chosen our paths from our start pose to our end pose, we also need to put in our heading, which means that in our case, we are not actually going to spin or rotate around. If we were to change the heading at the end here, let's say we did it 180, now you'll notice that the heading changes throughout the motion of the path. There's a couple different ways you can set this up, where you can set it up linearly, you can set it up so it has different curves as it sets up, but in this case, we're just going to do a straight up linear path so that it doesn't move. So I'm going to do dot set linear heading interpolation. And in order to get our headings, because we already did our poses up here, we can simply do start pose dot get heading, and then we're going to do our shoot pose dot get heading. And the last thing we do to actually do that path is dot build with a semicolon. And that is how you create a path. So now comes time to, now that we have our paths built up, it's time to build a sort of state machine manager where we can update every single loop, because we want to update this about 50 times a second roughly. Or is it once every 50 milliseconds? I can't remember. It's quite fast how quickly this thing iterates over. I think it takes about 13 milliseconds for it to get through a single loop. I could be wrong on that. But we want this to be able to update quite quickly. So we're going to create a little bit of logic here to allow us to update our path state and actually manage our state machine that we can call every single loop, so we don't have to have any breaking lines. So we're going to make a new public void, and we're going to call this one state path update. Takes no arguments. We're going to put in a switch statement. So we'll put in a switch. And in this case, it will be a path state. And now we start putting in our cases. So our first case is our drive from start position to shoot position, because that's the first state that we're going to end up being in. And because our state machine names are quite clear, it's pretty obvious that this is a driving state from the start position to that shooting position. So inside this, we're going to say follower dot follow path. And the path that we want to follow is our drive from the start position to the shoot position. Then we're going to add a second argument here for the value of true. And what this hold end does is you can now set that true or false, And for true, it's basically going to hold that robot in that position on that final point that you want it to be in that second pose. Then we're going to immediately transition states. So we're now going to say that our path state is going to be equal to our path state.shoot preload. And that might seem a little bit confusing, but we'll talk about this logic in a moment. And then we'll put in a break to make sure that we finish that case. Now we're going to put in a second case to make sure we do things. And this is going to be the things we're going to do inside of our shoot preload. Now the first thing we have to do if we're inside this state is we need to check, is follower done its path? So to be able to do that, we're going to say if, our follower dot is busy, but we're going to say not. So if our follower is not busy, and this is busy basically will return true if it's still following a path. If it's finished its path, it's going to say false. So whenever it's done its path, that means we have finished the path from our previous state. Oops, I'm in Python mode again. And at this point, this is usually where we would add in our flywheel logic. But because in this case, we actually don't have anything for this, I'm simply just going to say telemetry.add line, and we're just going to say done state machine. Or we can just say done path 1. Just so we can see that that's clear. And then we're going to put in a break at the end of our statement here, because in our state machines, if we don't put in break, it will just continue to follow the next state in line. And then typically here, we would also transition to next state as well. Now, typically in state machines, you also want to put in some sort of default connection. And for default here, we're simply just going to break and say telemetry.add line, and we'll just simply add in no state commanded. Oops, commanded, so that we know that if this ever comes up, we've actually told our robot that we're currently not in a state that we would expect. Now, a bit more setup here, but we're going to keep going. Now we're going to make a bit of a helper function. What this helper function is going to do is it's going to let us have a timer that can keep track of how long it took each path to finish. So I'm going to make a public void set path state. And in here, we expect and for that object, we're going to say new state. So this is basically going to allow us to transition our path states. So in the set path state, you could almost call this, transition path state if you really wanted to. And we're going to say that our path state is going to be equal to our new state. And we're also going to make that path timer dot reset the timer. And this just stops us from having to type in reset timer every single time we call a new path. So now we could do, now that we have that logic set up for that path state, we can take this section out of here, and rather than making it as just a simple path state, we want to reset our timer. So we can say that our set path state, and we can call this one with a new path state, which is going to be path state dot shoot preload. And this will both reset the timer and make new state at the same time. So it's a nice little helper function for us. So now we're almost ready to actually start running this. Inside this init statement, we can create a couple new objects here. First thing we need to do is we need to set our path state. So we can our path state is equal to path state dot start driver position and go to the shoot position. So that's always going to be our first path state when we start our program. Then we'll make a new path timer. So we'll say path timer is going to be equal to a new timer. And then we're also going to make an op mode timer is going to be equal to a new timer. So we can keep track of how long our op mode's actually been running for as well. At this point, we can also reset our op mode timer. So say op mode timer.reset. And we're not going to reset our path state because this is just the init. We want to do that when we actually start that position. Next up, we need to make a new follower. So we're going to say our follower is equal to constants.createFollower. And we're going to pass in our hardware map. And this creates the actual follower object. Then in here, usually you would add in any other init mechanisms, limelights, your flywheels, whatever that would end up being. In this case, I'm just a drivetrain. Then at the very end of this init, you need to make sure you actually call that build paths method. And then we're going to set our starting pose. So we're going to say our follower.set pose. And we're simply going to put in start pose. And that's going to tell our robot where we are in physical space. Right at the start, in this case, we are going to be starting right up here at the beginning. Oops, that actually is not correct because I just changed visualize. We're going to start right about here. And actually now I'm thinking we probably don't even need this op mode reset timer here. it's not necessary at this point in time. We'll do it later. Now, before we get into our main loop, we want something to happen when we actually press that start button. So we're going to make a new public void start method. And inside the start method, we're going to do two things. We're going to set our up mode timer. We're going to reset the up mode timer. Then we're going to use that set path state with that little helper function. We're going to transition to that new state, and we'll call our current path state, which is this part here. The reason we call this one now is so that it allows us to both set that state and reset that timer. It's also just a decent function for us to keep track of where that path state is. Now, true, on this init, you could also set it here. Not really necessary, but it's just what I've done. Now comes time to do our loop. The first thing you always have to do in your loop is our follower.update. You have to call our follower update or it will not start actually updating with those PedroPathing positions and coordinates. In our case, we're also going to update our state machine. So in our case, we call this one state path update. So we're going to also call state path update. And we need to call these two every single loop so we can update where our current position is in time. Then I'm going to put in some simple telemetry data here. We're going to grab what our current path state is. So we'll call that path state to string so we can print out whether we're in the drive start position, shoot position, whatever it is. Then we'll grab that follower get pose, their current X position, their current Y position, their current heading, as well as how much path time has actually elapsed. So at this point, your first auto is done. There's a lot of things going on here, but when we click play, what should happen is we should move back and then just hold there at the end of that position. So let's test that actually works. So let's go ahead and connect over to our robot, build this up, and let's see what happens. All right, so I've got the panels dashboard set up here. We're going to set it to a PedroPathing section. Now this actually isn't going to show anything because I haven't actually drawn the draw object inside of my class here, but we are going to be looking mostly for the telemetry objects here. So I'm going to go autonomous. We will select the sample auto pathing. We'll go to initialize this up. When we click start, we should expect that our robot moves back and then stops and holds its position. And while our telemetry happens to not be updating, if I come over to my camera here, let's go over to webcam. And we can see that right now we're done path 1. Our path state is in the shoot preload and our X is at 48, our Y is at 96, our heading is in radians, and then we can currently see how long it's taken our path to run this. So let's go ahead and try that one more time, and I will show you the telemetry the entire time. And then start, and we can take a look at our telemetry. So we can see our telemetry updating over time as we go. And let's go ahead and stop that. So you've now successfully built your very first path. But at this point, it's not very good if you just have one path in here. So let's go back to this visualizer. And let's add in a second path. So we're going to add another line. And for path 2, all I want to do is move my robot off of that second line. So we're simply going to move in here and then rotate. Now, we might not do a tangential. We'll keep a linear heading here. And maybe let's try a little rotate here just so you can see that. So we'll go from 138 over to 90. So if I were to play this, you'll notice that our robot is going to rotate to look straight up, just because I want to show you how that rotation works. I don't think you'd actually want to rotate 90 degrees, but we can show you that so that we can actually have that happening. So let's try this to do our pose and how we would add in a second pose here. So to be able to do that, now that we have that main logic, adding in additional poses and things like that is really easy. So I can come down to this, my poses, and we're going to add in another pose. So we'll say private final pose, and we're going to call this one our end pose. We'll make a new pose, and we need to grab our X positions. So we're going to go ahead and grab our endpoint of this X value like so. We'll, of course, swap out our comma with a period. We'll do the same thing here. We'll put in our Y. And then because we want our heading, again, we're going to do that math dot to radians. I'm going to put in 90 degrees, just as I want to show you a little bit of rotation. And now we've got our new pose to the final. We need to add in another state for our robot. So we're going to end up shooting our preload. And then this one's going to be a drive state, and we're going to call this one from shoot to end. Actually, let's call this one shoot position to end position. And then inside of our path chain, we now have a second path. So in this case, this new path is going to be drive from shoot position to the end position. And we need to make another path here. So we're going to call this one our drive from our shoot position to our end position is a new follower dot path builder. And of course we have dot add path. This is a new Bezier line. And we're going to go from our shoot pose, because we're already going to stay in that shoot pose, to our end pose. We're going to set our linear heading. Oops, we don't want a semicolon there. We're going to say dot set linear heading interpolation. And this one is going to be that start heading, which is going to be from our shoot pose dot get heading to our end pose dot get heading. And then of course we need to dot build with a semicolon to be able to finish that off. We can now come into our states. In this case, we now have a new state here, which in our case is case drive from the shooting position to the end position. And if we're in this state, this is typically when we are all done. So we can just simply add in if our not follower dot is busy. We will grab this line here where we'll say done path 1. I'm just going to say done all paths. And we'll put in a quotation mark here. So now, because we added another path, we have to be able to have something happen with this shoot preload. When you're shooting, you probably are not going to finish shooting all those things by the time you're actually done your path. So in this case, we're going to say check we're done our path and check that 5 seconds has elapsed. So now we're going to check if the follower is not busy. That means we're not done. And we're going to grab that path timer dot get elapsed timers in seconds is greater than 5 seconds total. So now we have a combined conditional statement here. Our path is done, and that whole path has taken more than 5 seconds. Now keep in mind that whole path includes the time it takes to move on that path and the wait time at the end of that path. So it's both together. So at this point, we're going to assume that our flywheel logic is done. So we're actually going to remove this to-do object in here, and we're going to transition our state. So we're going to say that our follower dot follow path, and the path we want to follow is our drive from the shoot position to that end position. And again, we're going to put in the true value here because we want to hold that final point. Then we need to transition our state. So we're going to say set path state. We're going to put in path state dot from the shoot position to that end position. And then of course, after that if we'll break. So at this point, there's nothing less for us to end in. So as we write this, our robot will move back, it'll wait 5 seconds, then it'll turn and rotate. And it might not wait perfectly 5 seconds because it might take us about 1 second to actually get back to that initial point here. So let's go ahead and build this. I'll pause that so we don't have that green line moving the entire time. Let's build this and let's watch what happens. And then when we press start, we should back up, wait about 3, 4, 5, and then we should transition to our next state. Beautiful. So let's take a look at our telemetry data here. We'll go ahead and start up our autonomous pathing. Ooh, we'll rotate that a little bit. So we come back. We're currently in our shoot preload state. We see our timer. Once our timer goes to 5 seconds, we transition back to that point. And now we're in the drive shoot pose to end pose state, and all of our paths are done. We can go ahead and stop this, and that's it. If you'd like access to this as a code snippet, you can consider joining the community down below, and that'll also give you access to other things like CAD resources and other things I've made for robotics projects. If you got questions on this tutorial, let me know in the comments down below. I'll do my best to answer them as we go. You can also consider joining the PedroPathing Discord. It's a fantastic resource for where you can get different resources and different help from some of your peers. As always, I hope you found that helpful in working through some traditional state machine logic and some fancy different pathing, and best of luck out there this season.